What is sound? Take this mandolin string. As it is plucked, the strings vibrate. This vibration produces sound waves that move away from a sound source, like this water glass ripple from Jurassic Park, but in a spherical, three-dimensional pattern. This sound wave can be picked up by a transducer, like a common microphone. There are three main categories of microphones: dynamic, condenser, and ribbon. These transducers turn the sound wave into an electrical signal of voltage that mimics a sound wave. This voltage
is itsy bitsy
and needs to be amplified by a preamp for it to be recognized. In most consumer products, these are built in.
It's kind of like your volume.
Once the voltage is big and strong, it needs to be digitized to be stored and manipulated by our computers.
You're turning my sweet analog voltage to ones and zeros.
Yes, sir. These ones and zeros represent the sound based on math from two categories of numbering: bit depth and sample rate. When your audio is digitized, the computer recognizes it like snapshots or pictures. The number of these snapshots at any given time is the sample rate. The more of these, the smoother the audio picture, and the more of them smaller, higher frequencies we see with our ears. Standard CD sample rates are 44.1 kilohertz, and DVDs can be 48, 96, or 192. That number comes from this Nyquist theorem. That states whatever our frequency range, the lows
to the highs.
that you want to hear, well, that number's got to be double. For instance, we hear from about 20 hertz to 20 kilohertz. That's where we get that 44.1 from. Double the 20 kilohertz. Plus some math, slope, roundage stuff that's going. Now, when you think of a sound wave taken in snapshots, what does it need? Depth. The sound wave needs steps in the ladder to represent the change in voltage. This is the bit depth. CDs are 16-bit, DVDs are 24-bit, and them old video games, well, they used to be 8-bit. The higher the bit depth, the more dynamic range, the difference from the loud to the soft, that you can hear. To calculate the dynamic range, multiply the bit depth times 6. CDs, 16-bit times 6, that's 96 dB of dynamic range. DVDs, well, those are 24. Multiply that times 6, and that's 144. You usually, as a rule of thumb, want to record at the largest bit depth and sample rate to get the best quality possible. Now, this can take up a lot of space, but nowadays there's these external drives that are the size of the Milky Way for $2 and growing cheaper every day. If your audio is the best going in, you can always hack it off its bits and then turn it into an MP3 or any other type of file thereafter. There are lots of different files that you can convert to. MP3, WAV, AIFF, FLAC files, each with their own application. You need some good converter software in your toolkit. Most computer media libraries do the basic MP3 WAV conversions. But here are some alternatives. Once you pick your file type and play it back, the process is then reversed. Them ones and zeros go back into electricity that goes into your amp, into your new transducer, to your speakers.
Wow, so my mandolin song went from a wave to a voltage to ones and zeros, and then was chopped up, squashed, and compressed, turned back into a voltage to a wave to my ear so I could finally hear it?
Yup.
Cool.
And that's just the basics.